Here we are given four functions to find the domain. Remember, the domain of a function is the largest set of definition of that function. We have the function f of x is equal to 3 all over x. Now we know that dividing by 0 is impossible in mathematics. So here, the domain of this function will just be, we call it dom f, will just be any real number except the value 0. Because if x takes the value 0, we're going to have 3 divided by 0, which is undefined. So this function here can take any real number but 0. So the domain of the function is any real number except 0. The second function, g of x, is equal to 1 minus x all over x into x plus 4. Here again, we have a rational function, and we want to avoid the situation of dividing by 0. Anything divided by 0 is undefined. So we want to make sure that the values of x that we take to put in this function will not render the denominator 0. So how do we get that? All we need to do is to set the denominator to be equal to 0 and solve. So when we do this, we're going to have the product of two expressions giving us 0. So if that is true, then either x is 0 or the second expression x plus 4 is 0. Now, if x plus 4 is 0, this means x is negative 4. So the two values of x that we really have to avoid will be negative 4 and 0. Consequently, the domain of this function will be any real number except the two values negative 4 and 0. Okay? Now let's take the third function. Let's take the third function. The third function is h of x is given as the root of 1 minus 2x. Okay, we know that square root of negative numbers do not exist. And so the values that we're going to avoid here will be the values that will render 1 minus 2x negative. And so we are forced to solve the equation. We're supposed to solve the inequality 1 minus 2x less than 0 to find the set of values that will render this expression here negative. Remember, less than 0 means negative. Okay, so we want to see the set of values of x that will render this expression negative by solving this inequality. Here we take negative 2x to the right hand side. We have 1 less than 2x. If we divide all through by 2, we have a half less than x, or x greater than a half. Okay, so it simply means all values of x to the right of a half is going to render this expression here negative. And if this expression becomes negative, then the square root sign will be impossible. We will not be able to get the square root sign in the set of real numbers. It will only be possible in the set of complex numbers. Here we assume we're working on the set of real numbers. So the domain of this function will therefore be all real numbers except all values to the right of a half. Will be all real numbers except all values to the right of a half. Okay? That will be the domain of this function. Now, when we take the last function, L of x is equal to log natural log of x squared minus 1. We all know that the natural log function lim is not defined at 0 and negative values. Okay, so we want the expression x squared minus 1 never to become 0. We want the expression x squared minus 1 never to be negative. So we have to solve the inequality to get those elements that we have to avoid. We have to solve the inequalities x squared minus 1 less than equal to 0 to get those values that can render this either 0 or negative. Okay, so finally we have this quadratic inequality to solve. We do not make the error to come and take negative 1 to the right hand side to have x squared less than or equal to 1 and then later on looking for the roots. That is not the best way to solve this. We look at this and we quickly see that it is the difference of two squares. And so we write it as x squared minus 1 squared less than or equal to 0. Okay, so that we can see it clearly. Remember, 1 squared is the same as 1. And so using the identity a squared minus b squared to be the same as a minus b into a plus b. Using that identity, we now transform this. This corresponds to the left-hand side here. We want to transform this to the identity that we have on the right-hand side. So here, a becomes x and b becomes 1. So we say x minus 1 into x plus 1 less than or equal to 0. Okay, now we have the product of two factors less than or equal to 0. So we have to proceed by looking for the critical points. We set x minus 1 equals to 0. So the first critical point is x equals 1. We also set x plus 1 equals 0 to have the second critical point to be negative 1. Now we go on the number line and we place those values. We have negative 1 and we have positive 1. Now we're going to test three zones. This zone, and this zone. So we take a value in this zone. A good value in this zone could be negative 2. We're going to put it here. When x becomes negative 2, we have negative 2 minus, let's do it here. When x becomes negative 2, we have negative 2 minus 1 into negative 2 plus 1. So this gives us negative 3 into negative 1. The product is positive. So we're interested in the sign. So here, the sign here is positive. Now let's take a value here in this other zone. A good value here could be 0. All right, and we carry out the same analysis. So we put x to be 0. We're going to have 0 minus 1 into 0 plus 1. This is negative 1 into positive 1. So our answer is negative. So this zone is negative. Let's take a value here and we do the same investigation. A value here in this zone, this is 1. A value here could be 2 and any other value greater than 1. So let's take 2 for example. We'll put it there. Remember, we're working with this. So we have 2 minus 1 into 2 plus 1. Now let's check. We're interested in the sign only. So 2 minus 1 is positive 1. 2 plus 1 is 3. So this gives us positive 3. So our answer, our sign here is positive. But when we look at our inequality, we say less than or equal to 0. So this is actually referring to negative values. Less than 0 means negative values. So the zone that will be acceptable will be this zone. So here we have values that we have to avoid. This zone here will produce for us values that will render this expression or that expression either 0 or less than 0. And we don't want to have 0, and we don't have any values here less than 0. So this zone is a zone to avoid. Therefore, conclusion, therefore, the domain of the function L will be all real numbers except this set of values. Okay? The domain of that function L will be all real numbers except values between -1 and +1. If we take any value here, it will either render this expression 0 or will render this expression negative. And the log of negative values don't exist. Log of 0 equally don't exist.